Okay, let's give a warm welcome to Ignat Porchikin on his talk on Linux user namespaces.
Hi, thanks for coming to my talk. My name is Ignat, I'm from Cloudflare. Today we're going to talk about Linux user namespaces. Who here knows Cloudflare? Oh, okay, I won't explain what we do. A little bit about myself. I do Linux at Cloudflare. I'm passionate about system security and performance, and I enjoy low-level programming. Linux kernel, drivers, bootloaders, and other stuff written in unsafe languages. This is our agenda for today. I have a lot of slides, so I'll go quick, but it will be mostly pictures. So, all right. Just to recap, how containers contain. Who here knows the difference between a VM and a container? Okay. All right. So, containers like Docker is implemented in Linux via namespaces. So, these are Linux kernel primitives that allow you to do some separations of resources. One of the first ones introduced into the Linux kernels was a mount namespace. But to understand mount namespaces, let's revise what is a mount tree. So, when you have a Linux system, you have your root file system, usually mounted at /, and then you can mount other file systems at different file paths, right? And this is kind of constitutes your mount tree. Now, with mount namespaces, what you do is, and by the way, namespaces Linux are created by clone or unshare system call. So when you create a mount namespace, what happens? Well, you get a new you get a copy of your mount tree. But why would you need that? The nice thing about it is basically you can operate on this mount tree without affecting the parent mount tree, right? So not the parent, the initial mount tree. So you can unmount file systems. You can mount new file systems, and yeah. Why it's used? For example, in containers, it's used to limit some access of applications to file systems. So the traditional before mount namespaces were introduced, the approach to restrict an application access to a file system was chroot. So you have a root file system, and then you created some kind of another root file system in some directory and issued a change root system call and kind of separate. And if your application is running in this chroot environment, it has limited access to the file system. So for example, if the application suddenly becomes malicious, it should not access the root file system. But in practice, it's usually very hard to implement properly, and there are still ways an application can, what they call escape the chroot environment. So, and there is for example, if you got bind mounts or you forget about file descriptors, link, virtual file system, procfs, etc. So there are many ways a chrooted application can still influence potentially the root file system. The way how they do it in containers these days, so instead of creating a chroot, they create a new root file system in a directory, but once you move to a mount namespace, they do a system call called pivot root, which is essentially takes your root tree and turns it on the side, right? So your new root becomes root and your old root becomes a directory. And because you're now in a mount namespace, you can basically unmount that completely and it's gone. And then when the application becomes malicious, well, it wants to escape, but it has nowhere to escape to. Cool, right? So this is all these commands have been pasted from a real terminal. So this is a demo. So let's see, this is my dev system. I have some file system mounted, right? I'm creating a new mount namespace. And in my mount namespace, I can unmount one of the file system, like my user file system on TAPFS on this directory, right? And I can now check that I successfully unmounted the file system. But when I exit my mount namespace, I can check that my file system is still mounted. So I am actually affected the copy of a mount tree and not the real tree. network resources or network namespaces. So what are traditional network resources on your system? Your networking cards, your routing configuration, your firewall configuration, and like some other operating system config, like sysctls and other stuff. So when you create a network namespace, what happens? What you get? Well, you get literally nothing. Well, not nothing. You get like a dedicated network namespace with a local host interface. But what can you do now? You can like basically move NICs to this new network namespace, and in this network namespace you can have your own routing configuration, your own firewall configuration, and your own separate operating system configuration. And the way how containers do it, you can also create a special virtual Ethernet pair called a VETH device, and you can put one which is basically a virtual network interface, pair of network interfaces connected by a virtual cable, and you can put one end into the network namespace, and this is how can you communicate with namespaces. So a simple example. So here is my primary network namespace. I have some network interfaces here. I can create a new network namespace, and I don't have anything. And basically, if I want to reconfigure it, even my local loopback interface is down. I actually have to bring it up to make it work, right? And I can influence that configuration. And here is another example where two processes, like two network namespaces, can communicate. So in my network namespaces, I create a virtual Ethernet pair and tell it that one end should go to the initial namespace, network namespace 1. Now I have one of the ends in my network space, and my initial network namespace has the other end, left and right. Right, and I can put an IP address in my network namespace and bring up the interface, and I can also configure an IP address in my initial namespace, bring it up, and then I can communicate between these two namespaces as if they are separate computers. Very useful to do like some network testing on Linux without having to spin up a full-featured virtual machines. And the nice thing about it, all your network resources are bound to your network namespace. So if I destroy the network namespace, I can already see that all the resources are gone, including the VASP pair and I send to another namespace. So it's all automatically destroyed. Now let's talk about users. So your Linux system has users with a user ID. So user ID, root is usually user, not usually, it's always user 0. Then you have some system users, and you have some users, right? So when you create a user namespace, what happens? What do you get? Well, you kind of have the same set of users as in initial namespace, but you can create mappings. So for example, in your namespace, I can map Ignat back to Ignat, which is not very useful. I can map Alice, which becomes a daemon user ID 1 in the user namespace. And the most powerful thing is I can even map myself to a root user in the user namespace. So here is a simple example. My ID is 1000 on my development machine. I create a user namespace, and by default it's 655 something, so even Linux doesn't understand what user it is, so it says nobody. Yeah, so I have a different user ID. Yeah, I can map my user to a specific user ID. So here I'm binding myself to user ID 1. So in this case, I'm becoming a daemon user in my user namespace. And I can map myself even to any user ID, which doesn't even exist on my target system. So 1337, it still will work, but like Debian will tell you that you have no name in configuration files. And the most powerful thing, I can map myself to root, right? And now I'm root. There are other namespaces which I omitted because I only have 30 minutes, but yeah, you can. There are many other namespaces using containers PID, cgroup, etc., which can also separate your resources. Now let's talk about unprivileged user namespace. If you're attentive enough to my demo, you will see that this is how I created the mount namespace, and this is how I created the user namespace, right? So with the mount namespace, I had to use a super user privilege, and user namespace I could just create without any privileges. Moreover, I can create a user namespace without any privileges and become root in this namespace, right? So this is cool, right? Is this, yeah, I'm becoming suddenly, I wasn't privileged and now I'm root, right? So this is the ultimate privilege escalation, right? You're not privileged and yeah. Well, not exactly, right? So for example, if I create a user namespace, map myself as root, I see him as root, and now I want to mount a file system, do a privilege operation. I try to mount it, I still get permission denied. And why is that? Because user namespaces in Linux are somewhat special. They can control other namespaces. So like initially you have all the initial namespaces, and the initial user namespace is set to be owning other namespaces. So what happens is when you create a user namespace, a new user namespace, and you issue a mount command, you're still acting on the initial mount namespace. And the permissions are checked not against your new user namespace, but your permissions in the initial namespace. So this is like the operation is checked against the initial namespace, and because you are not privileged there, your mount is prohibited. So how would that work? So what you all can do is when you're created a new user namespace, you can create a new mount namespace. So you can create a copy on the mount namespace, and then you can basically operate on it, and then the privileges will be checked against your new namespace, and it will be allowed. So let's try that. So I'm in my user namespace to successfully mount an TAPFS. Now I can create another mount namespace, and then I can actually successfully mount a file system. And yeah, TMP is a mount point now. So apart from containers, why would you use that unprivileged user namespace operations like unprivileged containers? And as an example, let's review how Chrome is actually a very safe browser. They have like this multi-process sandboxing model. So first of all, each of your Chrome tab runs in a dedicated process. So the first layer of defense they use is basically your operating system process address space isolation. So one tab cannot actually influence the memory of another process. Then on top of that, they put each process into this unprivileged container, which some namespaces like mount, PID, and network. And on top of that, they also like wrap it in a seccomp profile. So like especially the stuff that parses HTML, like an untrusted input from the network, it has very limited view of your original file system, almost nothing. And if you're interested in details, they have this page written there. There is another project like rootless containers, which allows you to run basically Docker but without root, which is very useful. For example, systemd core dump, if you check their source code, when they process core dumps, they fork itself into a container using unprivileged user namespaces. So like it can process core dumps in the same way without affecting the system. Also various testing frameworks. When you need like fake root application or stuff, you can use unprivileged user namespaces. So in a nutshell, unprivileged user namespaces are a great tool for application to create effective sandboxes and harden their security. Or are they? It's a really cool tech, right? But when you read every security hardening guide for Linux, you see this. Like this is an example for Arch, but you can find it whatever. Like if you want a security hardened kernel, disable unprivileged user namespaces. So you see it everywhere. Disable unprivileged user namespaces. Disable. All security folks tell you to do it. And why is that? So this is like our Cloudflare example. It's a tale of a kernel bug that we discovered in 2022, but it started like a long time ago. This is a snapshot from our Jira. So like one of our engineer and ClickHouse team was experimenting with traffic control configuration on their servers, and they found a configuration where they can just literally configure and basically crash the system. So and they found it in 2019. Right, so My team reported it to upstream and said, like, yeah, you have this bug when you do X, Y, that with a perfect reproducer, the system crashes. I sent it to the mailing list, and here was the response. Like, nobody cared. And it's reasonable, right? So, like, this is the full reproducer of the bug. And yeah, you need to have a super user privilege to crash the system. So, like, is it a problem? Yeah, like, yeah, it's a bug, right? So the system admin can crash the system. Well, you can do the same thing officially in Linux by so it's not really a bug, right? Then we kind of fast forward to 2022, and we were working on some network namespaces, like, and have this idea in mind. It's like, hey, after all, why not? Why can't I unprivilege myself into the container and try to mess with traffic control? So here is how to promote a bug to secure vulnerability. So this we're on Linux 6.1.5, which was the last kernel where the bug wasn't patched. So here I'm a not privileged user, so I'm just creating a user namespace, configuring the localhost interface in it. Then I basically run the reproducer, and like now it's configured, and all I need to send one packet through this network card, so like one ping. So if I send a ping, my system crashes. I actually also submitted an internal bug to our Kubernetes team. Hey, please update the kernels on the Kubernetes cluster. And it's like, are you crazy? Like, we run containers, you can't crash the system. I said, look at your dashboard, one of your servers will go down now. So say, okay, like, kernel was upgraded within like 2 days. Turns out we're not alone in this case. So there are a lot of CV, there are a lot of kernel CVs is actually were just bugs, but because you have these unprivileged user namespaces, they being promoted to security vulnerabilities. And I mean, this is just like I was randomly doing through CVE database and found these, but like there are more, and they keep coming, why does it happen? Basically, because user namespace, unprivileged user namespace changed how you can reach some kernel code, right? So usually what you have, something like this in a privileged operation. So if you're not sysadmin, you get e-permission of doing something, and then you do the permission check and do some privileged stuff, right? So this is how it works. And this, some privileged stuff may contain bugs, right? So before, basically, unprivileged user namespaces, you can reach that code only as true root. But now, because you're kind of allow to the system to have unprivileged user namespace, even though the permission system does not, by default, should not allow you to do privileged operation, you can still reach privileged buggy code in the kernel, and then you can trigger the bug as an unprivileged user. So what do you do with unprivileged namespaces? Well, as some guides say, you can just disable them. Yeah, and it's not very great because you still need them, like Chrome needs them, for example. You have the sysctl, which is by default allows you how many user namespaces are allowed on your system. So you can create a user namespace, but then you can change the CTL and basically to 0 and to not allow it in runtime. But this is kind of like a cracking a nut with a sledgehammer, right? So it's still a useful functionality. The thing is, there is another approach which was never upstreamed properly, but many downstream distributions adopted it. So this, you may find online this guide, how to disable unprivileged user namespaces. So it's basically allow only privileged user namespaces. So unless you're root, you cannot create user namespace. But again, this is not an upstream kernel. This, you can find it in Debian, Arch, Ubuntu, but not if you're using vanilla kernel. And yeah, and this is basically, the camp is divided. So from one side, we need to disable unprivileged user namespaces because they create more vulnerabilities, but the vulnerability is not in the user namespaces itself. It's a path for you to reach vulnerable code in the kernel. But there is like other side of the coin where you need to keep we need to keep unprivileged user namespaces because they allow for more secure application like Chrome sandboxing, right? So, and the bugs in the kernel, it's not because of user namespaces, it's because there are bugs in the kernel. Let's just fix all the bugs, right? So let's fix all the bugs in the kernel. Why didn't we do it by this time? So like, should we disable or keep? Well, technically we can do both, right? How about, how do we allow some application to create user namespaces while prohibiting the other? So you can have some kind of like a policy saying like, yeah, Chrome is allowed to create user namespaces, but a random application downloaded from the internet is not. And policy in Linux is implemented usually in LSM, right? So you can, who here is familiar with SE Linux? You can configure it kind of via SE Linux, but if you ever touched SE Linux, it's very complex. So I learned it when I was working on Android at Samsung, and they were like, Android was just adopting SE Linux, and you need to have a whole dedicated team just for running SE Linux. So thank you. A good modern approach we use in Cloudflare is BPF LSM. Who here is familiar with BPF LSM or BPF in general? Yeah, so with BPF LSM, for example, in the kernel you have some functionality, right? And then you can write program in C or any other language which is compilable to BPF and put it in a hook somewhere. And here we need somewhere on the clone path, because clone system call is used to create user namespaces where when the process tries to create a namespace, we can kind of police and make a dynamic decision whether that process is allowed to create the user namespace. Unfortunately, when we started researching that, there was not a great hook in the clone path that we can use. The only hook we found was cred prepare, but it kind of created a weird side effect then when you attach a policy, and if you prohibit a program to creating a user namespace, you actually get an error code cannot allocate memory. And this is how the code was implemented. So you have the prepare creds, but it kind of like ignores the error code which you return to it. So like if you return any other, like eperm, for example, it will just still return enomem to the application. So this was not a great experience and create a lot of confusion for our SRE folks, because they're like, hey, why this program returns no memory if there is plenty of memory on the system? So we needed a new hook. So we proposed a patch to upstream to create a new hook just to have an LSM to be able to police creating user namespaces. The problem is like here be dragons. The problem is like the actual maintainer of the Linux subsystem for user namespaces was really, really strictly against any hooks, just for the reason they strongly believe that if you start policing user namespaces, application developers will not be encouraged to use user namespaces to create secure sandboxes. And we kind of had a long discussions, many months going forward, with still them saying, I don't want that in the upstream kernel. Luckily, Linux kernel is the biggest open source project in the world. There are a lot of folks, right? And it's kind of democratic. The community can decide where to go, right? Wrong. Only that guy decides. So the benevolent dictator, so unfortunately, because maintainer was against, we kind of brought, with other people from Linux security community, we brought the case to the benevolent dictator, and he kind of took our point. And I think it was like one of the few instances in Linux kernel development where Linus actually overrides the decision of the subsystem maintainer. So he actually accepted our patch into the main line, and now we have the hook. So now you can write, for example, a simple BPF program with a new hook called user ns create. And here, as an example, I'm writing a very not useful policy, but demonstratable. So, for example, if you have, if your program name starts with a T, you're allowed to create a user namespace, but if not, you're not allowed. So here is for the full code. You can also copy paste all of this and try it yourself. So you can compile this BPF program because BPF ecosystem is very hard to use. So you need to do this thing called skeleton, and then you need to recompile the program again with a skeleton. And basically what that does is like you open your program and then you attach it to a hook, and after that your policy is kind of enforced. So yeah, again, you can recompile after you generated the skeleton, you recompile the program as a normal program, and now you load the policy into the kernel, and then we can try it. So for example, in this case, now when I do try to create an unprivileged user namespace, my application fails and I have a proper error code permission denied because my policy prohibited it. But if I rename my application to trusted, it starts with a T, it works fine. But I mean, this is a simple policy. The way how we do in Cloudflare, for example, we have a policy which is effectively an allow list of application, a specific paths which are allowed to create applications. So we actually use unprivileged user namespaces to create sandboxing in some of our services, and we just maintain this allow list. And unlike SE Linux, it's very easy, so it's just a list of strings or paths, and like if other developers need to add themselves to allow themselves to create a user namespace for legitimate reasons, they just send a pull request and it all works. So BPF LSM in this way is very, very useful because it's simple, and unlike SE Linux, it's really like it's C code and it's understood by most developers. Yeah. So I think this is what I wanted to tell you today. So unprivileged user namespaces are a nice building block in Linux, allowing for better application sandboxing, rootless containers, and reduced need for set UID programs. However, uncontrolled namespaces may widen the attack surface by escalating simple kernel bugs to security vulnerabilities, and we can still get best of both worlds by utilizing Linux security modules to provide fine-grained application access to unprivileged user namespace functionality. And I strongly encourage you, if you haven't researched it, if you are selecting an LSM for your Linux system, do consider BPF LSM. It's a newish, more developer-friendly LSM, and which allows you to define your policy in a simple, programmable way without learning any extra stuff. One thing I also wanted to add, it's not on the slides, is like yesterday we had this talk on the main track, how to build your career in open source. And like the story here is a nice example. Like the phrase there was, you build up your authority in open source by contributions. But I wanted even like, this story even shows like that contribution from our company was made by an engineer very new to Linux kernel, and they still got their code in. It's like, it's not only how many contributions you made, but if you're doing the right thing and you're persistent and kind of know what you're doing, there is a path forward for you in open source. So this is some links you can use. So the man page is for Linux namespaces and specifically for user namespaces, which describes a special case of user namespaces and its relationships to other namespaces. And everything that I described today is kind of like described in our 2 blog posts on the Cloudflare website. So go read that. The code presented here is also available there, so you can copy, paste, compile it, and play in it yourself. Thank you very much. I don't know if we have time for questions.
Do we have any questions from the audience?
Going once. Going twice. Okay, thank you.
Okay. Actually, I have a question.
Yeah, okay.
So, what other interesting Linux contributions have you made inside Cloudflare?
Me personally, in 2020, I patched dmcrypt module. The dmcrypt is a thing you use for transparent disk encryption on your Linux system, and you should definitely encrypt your disks if you're using Linux system. So I basically, when we transitioned, like at that point we were transitioning from like spinning disks to SSDs and NVMEs, and we noticed when enabling disk encryption the performance wasn't great. So I went back and kind of like I call it made a JIT archaeology. So I reviewed every commit to dencrypt, and like the dencrypt design, it was overcomplicated in my view, and I tried to understand why. And it's kind of like every code is legit, but like if you review the git commit history, the code that went in dencrypt was having spinning disks in mind, whereas like the dynamics of I/O changed when you started having SSDs and VMEs. So I presented new options to actually. There was a lot of queuing and asynchronous processing, which kind of disables all of that and creates a simple, straightforward path for like here is an I/O structure, encrypted, passed down, and it's kind of sped up disk encryption performance like 10x or 100x on some workflows. So.
Wow, that's impressive. So any guys who are encrypting private keys on your Linux laptops, right? I think we owe this guy a beer.
Yeah. There are some questions.
How do you debug with those applications?
BPF LSM,
debugger?
the BPF program.
Okay.
It is a good question. So the ecosystem is quite young. So currently, and the programs are small. So like with BPF LSM, if you have a very complicated policy, you're probably doing it wrong because the code has to be, it's a security code and it has to be simple and easy to understand. Yeah, but the best way to debug simple small programs is printf debugging. So you can send stuff to debug pipe and read it.
Does BPF things have unit test cases or that can use or some or check for them?
Yes, I mean BPF. We write, for example, BPF in C, and there are like other frameworks which write in Go. So they are like programs in a simple programming language. You can technically compile them separately into dedicated programs and have unit tested on them. So like the harder part is integration testing because you want to insert them in the kernel and see what happens. Also, I encourage you to look at the Linux kernel repository itself. It has a self-test directory, and there are a lot of tests for stuff, and see how it's implemented.
Okay. I want to ask you, what's your opinion about that Linux allow if once you have a supervised authentication to mapping your roots map to your root directory, because it by your word it seems not a good idea.
To map yourself to your user to root, or
by your PPT, it seems you have a many way to map your user namespace to your root. It's right.
Yeah.
File system.
Yeah. No, it's not the reason is, the primary reason you can map yourself to the root user is actually that you're privileged enough to create other namespaces. So the whole idea of this concept is that you want to, as a normal user, because, for example, let's imagine you download a Chrome browser, right? And if you don't allow this functionality in the kernel itself, the Chrome browser package should contain a privileged application to create a sandbox for itself. So this is kind of an additional attack surface. So you have this privileged application, you're downloading from the internet, you have more ways of your system to be compromised. So the whole idea behind that is to allow applications and privileged applications to create effective sandboxing. And like my talk, this is where my talk doesn't have any opinions. My talk is like, I like user namespaces, but I acknowledge that they're dangerous. So if you have, you need to allow them, but you also need to control them in the way.
Yeah, because it seems very easy to be hacked.
Yeah,
So-
like I've been at security conferences, and security folks really love Linux user namespaces. So it's like, oh, that's great that nobody wants to disable them, because like this is our like bread and butter. But but also if you disable them, you also will do harm, right? Because you won't have effective sandboxing. So this kind of like I don't think like Linux kernel developers or someone else should decide whether you should do it or not. You have to have the administrative control on your system to decide what you can do, and you need to have this flexible decision making, right? So you can't just disable or enable. You want to say, I want to enable for these use cases, but disable for these use cases. And this is where the LSM policy is the best approach, I think.
So you mentioned the big distros. Are they still disabling this by default, or are they using the LSM policies actively? Like, what's the current state for like Ubuntu or Debian? And
I honestly didn't check whether they have adopted this hook, because we use upstream kernel in Cloudflare, but I think they will eventually, because like the SE Linux maintainer was very interested in the hook, and eventually it might propagate. But again, it depends on like what you read. So like Arch Linux, for example, by default doesn't disable it, but Arch Linux has a dedicated security hardened kernel which disables it. So like they provide a dedicated kernel for that, for example.
And second question, like if you're going to build an application which required sandboxing, so let's say like you wanted to build your own LeetCode application or something like that, would you try to use these features directly, or use some client library or something to actually actively like help you do everything correctly?
So again, I can give you an example of Chrome. What Chrome does is like they have a fallback, obviously. So the code try to create sandbox using unprivileged user namespace, but if they can't, they have this dedicated setuid privileged application to help overcome this thing. So kind of like, and this is like, can you universally understand that, like, does your system allow it or not? Like, as an application developer currently, and unfortunately you cannot predict, right? So you can either sandbox yourself, or decide you will not do it, or ship your code with some privileged application and try to explain to your users why you have this privileged application to create this sandboxing.
For the LeetCode use case, for running untrusted user-submitted code, I see the kids seems to be using this gvisor subsystem from Google nowadays.
Okay. But gvisor is different. It's kind of, it's like, it's almost like a virtual machine now. So I think if I remember correctly, gvisor has 2 modes. So it's actually a Go application. So in first mode, it uses ptrace to intercept all system call and kind of re-implements all the system code in Go. So when you run your code on gvisor, when it calls like file read, it goes not to your Linux system, it goes to gvisor, and gvisor does whatever it wants to do and then can pass through it or not, or do something else. I think the new implementation of gvisor actually uses KVM for that as well. So it's kind of like a virtual machine now. So it's a more strict way of implementing things, but the performance there is not great because we tried it.
Yeah, I would like to ask that it seems like if we can just like using change root or namespace to create such like maybe leak, that means that namespace is not fully closed or isolated. Am I understand it correctly?
Yes. Well, namespaces should be isolated, but the difference between containers or namespaces and virtual machines that you still have the underlying kernel, right? The namespaces run on the same kernel, and inside the kernel, the address space is flat. So if you implement the code correctly, they are fully isolated, but your code may have bugs, and this is where it gets exploited. So if the kernel code has bugs, it could be exploited through namespaces sometimes.
So you mean that in current design or current implementation is not fully isolated?
Yeah, I mean, design is isolated,
Yeah.
implementation is not.
I get it.